Today you're going to be finding the area of composite figures. All right, so a composite figure is made up of simple figures such as, now we're going to try to save some room and some writing here. A composite figure is made up of simple figures such as a triangle. Now, over here to the right of the triangle, I'm going to give you the area of a triangle. That's 0.5 times base times height, isn't it? Because you're going to need all of this together in one place for your assignment today. A composite figure is made up of simple figures such as triangle, rectangle. A composite figure could be a triangle on top of a rectangle. All right, this is base times height. A trapezoid. All right, a triangle on top of a trapezoid could be a composite figure. And the area formula for a trapezoid is 0.5 times base 1 plus base 2 times the height. Square, which is one of the sides squared. The area of a square is one of the sides squared. A circle, pi times the radius squared. Semicircle, that's half of a circle, right? So that area formula would be equal to pi times the radius squared divided by 2. So those are all examples, or all of the shapes, or most of the shapes that are going to make up a composite figure. All right, so some examples of a composite figure. If you look at, maybe you've got a, and you don't draw this, just watch, okay? Right here. Here's a composite figure. What is it? It's a rectangle with a triangle on top of it, right? Okay? That's all it is. Here's another composite figure. It's two rectangles, okay? If you were to add a dashed line here, you've got a rectangle on top and a rectangle on the bottom, don't you?
Yep.
That's what composite figures are. They could be a snow cone. Very good. That's a semicircle on the top and a triangle on the bottom. So anything that you can think of as a combination of shapes. All right? So now, to find the area of a composite figure, instead of to find, let's say this. let's say that the area of a composite figure is the sum of the area of the simple shapes. That make up the composite. Everybody okay with that?
Yes.
Okay. So we covered a couple of composite figures already, and let's cover or talk about an example when you're given a shape like a rectangle and it's got a circle in it, but this region here is shaded, and you're asked to find the area of the shaded. It's a little bit different, right? If you're asked to find the area of the shaded region, don't you have a rectangle with a circle inside of it?
Yeah.
Is the circle shaded?
No, just the rectangle.
No. So wouldn't it be the area of the rectangle minus the area of the circle?
Yeah.
Okay, good. And wouldn't that give you the area of the shaded? Everybody okay with that?
Yeah.
Yes.
How about this shape here? Maybe this is 12 and 8, 15 and 11. What do you see? I see two scenarios here, yes.
You can draw a little dot line to add that little triangle, and then find the area of the triangle and subtract.
Yeah, I see triangle.
I see a big rectangle
Yeah, that's fine.
minus a small triangle.
That's
Okay? Some people see a rectangle plus a trapezoid. Does it matter which way you see it?
No.
It's either rectangle plus trapezoid, right? It's either this rectangle plus the area of this trapezoid, or it's the area of the big rectangle all the way around the outside minus the area of this triangle. Both of those will work, won't they?
Yeah.
Okay? Both of those will work. However you want to find that area is how you can find that area. What do you see in this? This is going to be a little sloppy, but pretend everything's straight and those are Yeah, semicircles, and let's see, something like, and it's kind of like the inside area of the track out by the football field, right? And if you were asked to find the area of that, what could you break this up into? Very good, 2 semicircles. So if you did this and this, all right, you got half a circle on the left and half a circle on the right. Aren't these semicircles the same size as each other? So can't you just find the area of one circle? All right. What's the radius of this one circle? What's the diameter of that one circle? 22, isn't it? What's that? Yeah, 11. Right here. It's given right here. If this piece is 22, then isn't this piece 22?
Oh,
And isn't half of that piece 11, which also represents your radius? So you've got a rectangle that's 22 by 50, and you've got a circle with a radius of 11. Questions? Excuse me? Not really. I mean, we have been. I don't want to just waste your time by showing you how to find the area of a rectangle and showing you how to find the area of a circle and then adding them together. As long as you understand the concept of what you have to do, those are the examples that we're doing. All right, your assignment for today is on page 697. Problems 2 through 5, 9 through 12, 16 and 17. Don't do your work on your notes, because then if you have to pass your work in, you won't have your notes anymore.